But dear students, today we'll see the sixth part of your ECD lab theory, in which we are going to speak about what are conductors, insulators, and semiconductors. But this study now we will start from atomic structure, the smallest unit of matter, that is the atom. From atomic structure we'll start, and then we'll go to see the valence band and conduction band. And then, according to the energy bands, we are going to differentiate between conductors, insulators, and semiconductors. So let's start with the topic conductors, insulators, and semiconductors. Now, here, first we should know some basic things from where we are going and what we are going to study now. Now, here, if you see, if you start your you can start your explanation from what is matter. Okay, what is matter? What is matter? A matter is anything which has mass and occupies space. The matter can exist in the form of solid, liquid, or gases. In nature, matter is found in the form of either elements or compounds. Then after that, we will go to see what are elements. Then what are elements? When we say elements, what are elements? Now, it is a substance which cannot be broken into simpler substances or not possible to form simpler substances. They can be identified by a color or density, etc. For example, you can have oxygen, you can have aluminium, you can have germanium, etc. They all are made of identical atoms. They cannot be broken up. Okay, that is called as elements. Then after elements, we'll go to see what are compounds. What are compounds? In that, we can see that a compound is a substance which consists of more than one element combined in fixed ratio. It is a substance which consists of more than one element combined in fixed ratio. For example, you can have sodium carbonate. Then we will go to see one of our important feature. What is a molecule? What is a molecule? Okay, now if you see the definition of molecule, molecules are composed of two or more atoms. That means atoms are smaller than the molecule. Two or more atoms. The atoms of most of the elements cannot exist by themselves, and therefore they are generally available in molecules. So two or more atoms together make a molecule. Because atoms cannot exist by themselves most of the time, they are generally available in two or more sets, and those are called as molecules. Then what is an atom? Then atom has to be smaller unit of molecule. Then what is an atom? Atom can be defined as the fundamental basic unit of matter. Okay, so atom is the fundamental or basic unit of matter. If you take any matter, okay, the fundamental unit or the basic unit of that will be atom. So we will start our concept from what is an atom, atomic structure, and then we'll go to see what are the electrons in the last orbit called as. Then we'll see what are those valence electrons and then valence band of energy. And then when the valence electrons become free, they become our conduction electrons, and then we have conduction band of energy. And based on that concept, we can differentiate between conductors, insulators, and semiconductors. So let's start with the same concept. All matter is composed of atoms. Now, each atom will have a central nucleus. Okay, so each atom will have a central nucleus. So each atom will have a central nucleus, say like this, and one or more electrons traveling in the orbits around the nucleus. Around the nucleus, you will be having orbits in which one or more electrons will be there. Okay. Now here the nucleus contains of two things. This is the nucleus. It will contains of two things. One will be called as protons which are positively charged particles, and another will be called as neutrons which will be neutrally charged particles. So in the nucleus you have protons and neutrons. Now around the nucleus you'll be having orbit in which you'll be having electrons. Electrons will be there. Okay, now these electrons which will be there in the orbit or the shell around the nucleus, these electrons will be negatively charged particles. Okay, so here we see in the second paragraph, the nucleus contains of one or more positively charged particles called protons. The positive charge of a proton is opposite to the negative charge of electron. So how many protons you have in the nucleus, that many electrons you will be having in the surrounding orbits. In the sense that the total or net charge of the combination of protons and electrons will be zero. So if you are saying that protons are positively charged particles and electrons are negatively charged particles, then the number of protons in the nucleus and the number of electrons outside the nucleus will have the same type of positive and negative charges, so that electrically, basic level, the atom becomes neutral. Thus, an atom has the same number of electrons in orbit as it has protons in its nucleus. Therefore, an atom is electrically neutral. You cannot say at the basic level that it is positively charged or negatively charged. It is electrically neutral because of the energy. The positive energy associated with proton will be equal to the negative energy associated with electrons. Then if you go to see the structure of atoms, so here we have shown a figure where we have shown structure of atom. So at the center here you can see the nucleus. This will be the nucleus part, that is called as nucleus. And in that nucleus you can see protons and neutrons. Protons will be positive charge particles and neutrons will be neutral. Then around the nucleus you can see orbits. These are orbits. This whatever yellow round marks round you have shown, these are orbits. So these are your electron orbits, and in that orbits you can see this surrounding which are going around the nucleus in an orbit are called as electrons. So these are electrons which are negative charge particles. These are negative charge particles. So as a whole, the structure of an atom looks like this. You can show it in this way also, or you can show it in a two-dimensional way also. Like this, you can show. You can have a nucleus in between. In that, you can have protons and neutrons. Okay, and then surrounding the nucleus, you can have orbits, and in that orbits, you can show the electrons. Okay, so electrons can be shown here. So you can show the diagram in two dimensions also, or you can show it in this way also. Okay. Then same thing, we will more define it like this. Key protons will be your positively charged particles inside the nucleus. So two protons we have shown for simplicity. You have two neutrons. These are neutral, and this is your nucleus. This is your nucleus. Then around the nucleus, you'll be having orbits, 1, 2, 3, 4 orbits, anything, any amount, or depending upon the atom, orbits will be there. And in the orbits, you'll have electrons, which will be negative charge particles. So, okay, so here we have shown for simplicity, there are two protons and there are two electrons. Here one electron and here one electron. So number of protons in the nucleus will be equal to number of electrons in the orbits. Then if you see the study in detail, an atom is composed of two regions, the nucleus, which is in the center of the atom, and contains of protons and neutrons. We already told that. And the outer region of the atom, which holds its electrons in orbit around the nucleus. Then when we say atomic structure, what do we mean by atomic structure? The atomic structure of an element refers to the constitution of its nucleus and the arrangement of electrons around it. So whenever you draw a nucleus like this, nucleus, and around nucleus, whenever you draw the orbits in which electrons are going to revolve around the nucleus. Okay, so here you can have your electrons. Okay, and this will be the nucleus, and in the nucleus you'll be having protons and neutrons. Okay, so like this, if you draw a structure, it will be called as the structure of an atom, and this is the atomic structure, which shows you the nucleus and the electrons around the nucleus. For atomic structure, there is a atomic model according to Bohr. Bohr is a scientist, Neil Bohr. According to him, there is an atomic model which is most widely used atomic model to describe the atomic structure of an element. Now, what does this model say? Number one, it says that the electrons inside the atoms are placed in discrete orbits, different orbits called stationary orbits. These orbits are stationary. Okay. The energy levels of these shells or orbits can be represented via quantum numbers. Number three, electrons can jump to higher level, okay, by absorbing energy, and move to lower energy level by losing or emitting its energy. This is a very important concept, and this will be very important when we study optoelectric devices. So here, electrons can jump to a higher level from the lower orbit. If you want to go to the higher orbit, it can jump, but it has to absorb energy. Some energy are given to it, then only it can jump from lower orbit to higher orbit. But when it is jumping from higher orbit to lower orbit, then it can emit out energy or it can lose energy. It can radiate energy. Okay, this is a very important statement. Then number four says that as long as an electron stays in its own stationary orbit, there will be no absorption or emission of energy. If electron is in its own orbit, own shell, then there will be no absorption or emission of energy. Only if electron is moving from its lower orbit to higher orbit or from higher orbit to lower orbit, then only the absorption of energy or releasing of energy will come into picture. Then fifth point says electrons revolve around the nucleus in these stationary orbits only. Electrons will revolve around the nucleus in this stationary orbit. So these are some of the statements what are made based on this atomic model of Bohr. Then what do you mean by atomic number? So the total number of protons present in the nucleus. So only protons. The total number of protons, which are positively charged particles, present in the nucleus of an atom is known as atomic number. The number of protons of an atom determines the atomic number, and it is denoted by letter Z. Protons and neutrons both are there in the nucleus. Protons and neutrons together can be called as nucleons. But when you consider only protons, they are positively charged particles, and the total number of protons present in the nucleus of an atom will give its atomic number. Then what is mass number? The sum of the total number of protons and neutrons present in the nucleus of an atom is known as mass number. So the total number of protons and neutrons present in the nucleus gives the mass number. Then we'll come to our theory, our concept, which will lead us to our differentiation between our conductors and insulators and semiconductors. So for that, we should know how the nucleus and what are the orbits and how many electrons are there in every orbit and what are the energy levels. Okay, so here we have shown energy levels in an atom. So here you can see there is a nucleus in center here. This is your nucleus, which will have protons and neutrons. Protons will be positively charged, neutrons will be neutral. You will be having protons and neutrons here. And then after the nucleus, around the nucleus, you have the orbits, which will be called as shell. The first orbit will be called as as we have shown here, K shell. The second orbit will be called as L shell. The third orbit will be called as M shell. And the fourth orbit will be called as N shell. So you have K, L, M, N. Okay. So K for K, so here, or depending upon the placing of the orbit, for K we can take small n is equal to 1. For L, n is equal to 2. It is the second orbit. For M, n is equal to 3. It is the third orbit. And last n is equal to 4. It is the fourth orbit. Then what are these orbits and the electrons are associating with energy? Okay. So here we will see how many electrons will be there in different orbits. How many maximum electrons you can place in different orbits. So the maximum number of electrons that can be present in a shell or orbit is given by the formula 2n square. This is very important. 2n square, where n will be your position of the orbit, whether it is the first orbit or second orbit or third orbit. Okay. So n is the orbit number or the energy level index number, that is 1, 2, 3. So according to the first orbit, that is K shell, that is K orbit, you can take it as 2n square. So 2 1 square, which is equal to 2. That is 2 will be the maximum electrons in first orbit. In first orbit. Okay. Then if you go for the second orbit, it will be called as L shell. In that, if you take 2n square, 2n square, then 2 into multiplied by 2 square. 2 square is 4 into 2 is 8. So you can have maximum 8 electrons in the second orbit. Then if you go to M shell, it will be taken as 2 into n square. N is equal to 3 now. 2 into 3 square, 3 into 3 is 9, into 2 is 18. So here in the third orbit, you can have maximum 18 electrons. And then fourth shell, that is n. So n shell will be your fourth shell. So 4 square, 4 into 4 is 16, into 2 is 32. So fourth orbit can have your 32 maximum electrons. So here, electrons are not filled in a given shell unless the inner shell are filled. So if you see, if you're having a nucleus here and you are having first orbit, second orbit, third orbit. Okay. So depending upon how many number of electrons that particular atom has, the first orbit will be filled first with 2 electrons. Then we go to the second orbit, and the second orbit will fill with maximum 8 electrons. Maximum, if they are. Then if there are more than that electrons, then those electrons will be filled in the third orbit, where it can take maximum 18 electrons. If there are more electrons than that in that atom, then it will go to the fourth orbit, where the maximum electrons can be 32. Like that, the shells are filled in a stepwise manner, starting from inner shell to outer shell, starting from inner orbit to outer orbit. Then we'll see what do we mean by valence electrons. The electrons, those are present in the outermost shell of an atom, are known as valence electrons. Now say, for example, you take an atom. This is an atom. You are having nucleus. Okay. And around the nucleus, you are having your orbits. Okay. You are having your orbits. Orbit number 1, orbit number 2, and orbit number 3. Okay. Now these orbits will have electrons. Now say, for example, an atom is having 14 electrons. There are 14 electrons. Then according to our number of electrons per orbit theory, the first orbit will have 2 electrons. Second orbit will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is 10. Now remaining 4 electrons will be in the last orbit. Remaining 4 electrons will be in the last orbit. Now, these electrons which are present in the last orbit, these electrons which are present in the last orbit will be called as valence electrons. Electrons present in the last orbit are called as valence electrons. Therefore, our definition says the electrons, those are present in the outermost shell, that is the outermost orbit of an atom, are known as valence electrons. Then what is valence band? Then what we can say is the electrons that are present in the outermost shell, we know they are called as valence electrons. These valence electrons containing a series of energy levels. Okay, so every orbit will contain an energy level of its own. The inner orbit will have a lesser energy, whereas the outer orbit will have a maximum energy. So the valence electrons containing a series of energy levels form an energy band. If you take a single atom, then you can speak about an energy level. But if you see a set of atoms, then you can make that levels together to form a band of energy. Then it will be called as valence band, because here the valence electrons are there in the last orbit, and those electrons, the energy associated with that last orbit, will be called as valence energy. And if there are many atoms, though that energy can become valence band. The valence band is the band having the highest occupied energy. It is the outermost orbit, and it will be having the highest occupied energy. Then what do you mean by a conduction band? Now we are studying this valence band and conduction band because we want to study what is energy band diagram. Okay. Now these valence electrons which we have shown in the last orbit will be very loosely attached with the nucleus. The attachment with the nucleus, because electrons are negative charged particles, and in nucleus you have protons which are positive charged particles. So negative and positive energy will attract each other and there will be a bonding. But as these electrons, valence electrons, are in the last orbit, they are very loosely attached with the nucleus. Their attraction between positive and negative will be little loose, that even at room temperature, few of the valence electrons can leave that orbit and become free. These are called as free electrons. If the temperature is varying, it increases, the temperature can detach these valence electrons from the last orbit and make them free electrons. They can leave their atoms and move towards neighboring atoms. These free electrons are the ones which conduct the current in a conductor, and hence they are called as conduction electrons. And the energy associated with this conduction electrons, the band which contains conduction electrons, is called as conduction band. This is your conduction band energy. Then we'll go to see the first thing, which are called as insulators. Now, according to definition, insulators are such materials in which the conduction cannot take place due to large forbidden gap between valence band and conduction band. An example for insulators are wood and rubber. Now here, insulators are those substances in which no conduction takes place. So there are no free electrons. Now we have seen that when we had a nucleus here, and then we have orbits which shows the atomic structure in an atom, and we say that electrons present in the last orbit are called as valence electrons. Okay, so say this is last orbit, and here you are having around 4 electrons, say, for example. Now these 4 electrons, if they don't detach and come out, they won't become free electrons. They are associated with that atom only. Their attraction with the nucleus is maintained and they remain in the same atom. There will be no electron which can come out and become free and help a flow of electrons, which is called as conduction. So here this type of material will not help the movement of electrons. There will be no free electrons, so no current can flow in them. Like for example, plastic, wood or rubber. Okay. Therefore, we say that here the valence electrons which are associating with the valence energy band, they are full, but free electrons are not there, so conduction band is empty. So the gap between the valence band and conduction band is high, is more. The valence electrons cannot easily become free. That is why these type of materials are called as insulators. Now here you can see the energy band diagram. Okay, so here we have shown this is your valence band. This is valence band in which you can show your valence electrons. This will be valence electrons, and for insulators, these valence electrons in the last orbit will remain in last orbit. They don't become free because they are very tightly attached with the nucleus, and they cannot become free easily. So this valence electrons are there. This valence band is full. This is a full valence band, and this is a full energy. Now these electrons cannot become free, so the conduction band, because there are no free electrons, the conduction band remains empty. This remains empty. And the gap between the valence band and a conduction band, which is called as forbidden energy gap, will be very large, will be very large. So because this gap is more, okay, this valence electrons cannot become free and they cannot constitute the conduction band. Okay, so that is why here you don't get any free electrons, and because you don't get any free electrons, there is no chance of current to flow because the electrons cannot move, they are not free. They remain in the last orbit and they be associated with those atoms. They cannot become free, they cannot move. So there is no flow of current in this type of materials. For example, wood, plastic, okay, glass, etc. Then you can see here the insulator, some examples we have given. Any material that does not allow electric current to pass through it, like the protective coating on wires. Okay, so here you can see plastic is one example, rubber, glass, you can have cloth, you can have wood. All these are materials in which no current will flow. So that's why they are called as insulators. Then if you come to the characteristics of insulators, you can tell that in the energy band diagram, the forbidden energy gap is very large, and valence band electrons are bound tightly to atoms. It is full. All the valence electrons remain in the last orbit. They won't become free. There is no conduction. There is no free electrons. And third, the value of forbidden energy gap for an insulator will be of 5 electron volt or 10 electron volt. Okay. Then we'll go to see what are conductors. Then opposite to insulators, we have conductors. Conductors are such materials in which the forbidden energy gap disappears. There is no gap between valence band and conduction band. And valence band and conduction band are very close. They overlap each other. For example, you can have a copper aluminum. So here we can also say that conductors are the type of material in which large number of electrons are available for conduction. So again, if you see the atomic structure, this will be your nucleus, and around the nucleus, if you're having orbits, okay, you are having orbits, and in this orbits, the last orbits, the electrons in the last orbit will be called as valence electrons. So this will be, say, 4 valence electrons. Now these electrons in the material like conductors, like aluminum or copper, these electrons, which are called as valence electrons, can become free and come out. Okay, so this can become free and come out of the atom, and they can move towards the other atoms. So such many free electrons you get in a conductors. There is no forbidden energy gap between valence band and a conduction band. Okay, so you get many free electrons. A current can easily flow because the movement of electrons is there, because there is availability of large number of free electrons, and the conduction band is having many electrons, free electrons. So if you see the energy band diagram for a conductor, so here you can see there is a overlapping between valence band and conduction band. So valence band is the energy band which is associated with the electrons in the last orbit. Those are valence electrons, and then electrons from here can easily move to conduction band because they become free very easily, and there are many such free electrons available in conductors. Okay, so there is no forbidden energy gap in the energy band diagram for a conductor. There is no gap between valence band and conduction band. Then we can see some examples. A conductor, that is any material that allows electric current to pass through it. So you can have copper, you can have aluminum, you can have steel, you can have any metal which can act as a conductor. Then we'll go to see our characteristics of conductors. Number one, there exists no forbidden gap in a conductor. So there is no gap between valence band and conduction band, they overlap. Second one, the valence band and the conduction band gets overlapped. Third is the free electrons available for conduction are plenty. There are many free electrons available, so current can easily flow in this type of materials. And fourth, a slight increase in voltage can increase the conduction. If you apply a slight voltage, it can increase the conduction, it can increase the flow of current. Then we'll go to see what are semiconductors. Semiconductors are such materials in which the forbidden energy gap is small and the conduction takes place if some external energy is applied to it. For example, silicon and germanium. These are called as pure semiconductors. Now, when they are in the pure form, they will not act as a conductor. They will not help you in the current to flow. But when a small amount of impurity is added to it or any external energy is applied to it, then you can get free charge carriers which can make the flow of current, and then it can behave as a conductor. That is why this type of materials are called as semiconductors. Semiconductors are those substances in which the conduction and valence band are separated by a very small energy gap, about 1 electron volt. The conductivity of a semiconductor lies in between conductors and insulators. At low temperature, semiconductors behave like an insulator, and as the temperature increases, there will be more free electrons, and therefore semiconductor behaves as a conductor when the temperature increases. And the best example for semiconductors, the pure semiconductors, silicon and germanium. So this is a very important material. This is a very important thing by which we are going to study many semiconductor devices. And this property of semiconductor has shown a lot of applications. So if you see the energy band diagram of semiconductor, so here you can see you have valence band, the energy associated with valence electrons. You have conduction band, the energy associated with the free electrons. And the gap between valence band and gap between valence band and conduction band is very small. It is of around 1 electron volt. So if you apply some force, if you apply some external energy, these valence electrons can become free and go to the conduction electron, become a conduction electrons. That is, they become free electrons. Okay. So there is a small energy gap, so that has to be overcome, and then only the valence electrons which are present in the valence band can become free and constitute the conduction band. They become free, and then you can make a current to flow through it. Then if you go to see semiconductor devices, now here we have not shown material, we have shown devices. You can see devices like op-amp here. You can see ICs, you can see transistors, you can see diodes. You can also make a capacitor from semiconductor devices. You can also make a resistor from a semiconductor material. Okay, so here are some semiconductor devices shown. Then if you go to see the characteristics of semiconductors, number one, the forbidden energy gap between the valence band and conduction band is very small. The forbidden gap for germanium, Ge, is 0.7 electron volt, whereas for silicon, it is 1.1 electron volt. A semiconductor actually is neither an insulator nor a good conductor. As I've told you earlier, As the temperature increases, the conductivity of semiconductor increases. At low temperature, it behaves as insulator. At high temperature, it behaves as good conductor. So the forbidden energy gap for germanium semiconductor is 0.7 volt between your valence and a conduction band, as we have shown here. So this will be 0.7 volt for electron volt for germanium material, and it will be 1.1 electron volt for silicon material. Okay. Then we'll go to see a comparison of the energy band diagrams what we have drawn earlier. So for insulator, you can see the first one, insulator. For insulator, the valence band is full of electrons here. It is full of electrons, and there is a wide forbidden gap, energy gap between valence band and conduction band, and this conduction band is empty. There are no free electrons, so there will be no movement of electrons, there will be no flow of current in this. Then if you go to see semiconductor, the gap between valence band and conduction band will be very small. It is 1.1 electron volt for silicon. And if you apply some external force, if you apply some external energy, these valence electrons can become free electrons and help you for conduction, that is movement of electron, that is flow of current. Then if you go to see for a conductor, the valence band and conduction band overlap, and there are many free electrons. Valence electron become free electrons, and therefore there are a lot of electrons which are useful in a conduction. They will help the current to flow. Then basis of a comparison, you can have many parameters by which you can compare them. I have taken a few here. So first, the meaning. Conductors are substances that transmit heat or electricity through them. Semiconductors are materials that may act as conductor as well as insulator under different temperature conditions, and they are known as semiconductors. Insulators are the substances that does not allow heat or electricity to pass through them. Example for a conductor is silver, copper. Example for semiconductor is silicon, germanium. Example for insulator is wood, plastic. A conductivity in a conductor is very high. A conductivity, that is movement of electrons, a current movement in semiconductor, is moderate. It is in between a conductor and insulator. And conductivity in insulator is very low because you don't get any free electrons. There is no flow of current. Then next parameter is forbidden gap between the valence band and conduction band. For a conductor, both these bands are overlapping, so there is no forbidden energy gap. For semiconductor, this small forbidden energy gap will be of around 1.1 electron volt for silicon. And for insulators, there will be a large forbidden gap between valence band and conduction band. So there is no free electrons available. There will be no current flowing. If you see our resistivity, resistance, that is opposition to the flow of current, for a conductor, as it is having more electrons, free electrons, and it is easily allowing the flow of current, the resistivity is low. Whereas in semiconductor, the resistivity is in between conductor and insulator, so it is moderate. And for insulators, you don't have any free electrons, there is no flow of current, so the resistivity is very high. So these are a few parameters which we have compared for conductors, semiconductors, and insulators. Thank you, students.